Hello guys, welcome back to another episode of Learning with Satvik. Today we have a special request from a bunch of the sophomore class people to do a comprehensive review for the Chapter 5 test for Chemistry 1 Honors. So here we go. The first question involves a Hess's law problem for finding the change of H for this given equation. Okay, so let us begin. So first we see that we're given that equation 3C solid plus 4H2 gaseous equals to C3H8 gaseous. So the first step that we want to do is to try and find in these three equations the 3C. So let's scan. Oh, here we see a C. So because it's not 3C and we need to make it 3C, we can multiply every single term by 3. So that would just give us 3C solid plus 3O2 gaseous equals to 3CO2 gaseous. And then because we're multiplied by 3, we also multiply the change of H by 3 as well. So 3 times, and then for the second equation, which is the one that we used, it would be negative 393.5 times 3. So we can just write that down there. Please smash the like button as well, so we can keep producing more and more videos. Okay, so now that we found the 3C, we can check mark that. And then the next one that we need to find would be the 4H2. So let's scan. We see, oh, in the third equation, there's an H2. So that means, again, we would need to be doing the 4H2 gaseous plus 1 by 2 times 4 is just 4 by 2, or 2O2 gaseous equals 4 times that, so 4H2O liquid. So then change of H would equal to 4 times the negative 285.8. So 4 times negative 285.8. Okay, so now that we got the 4H2, we can check mark that. The final one that we need to find is on the product side, which is the C3H8. So let's scan. And then we can say that, oh, here in the first equation, it's on the other side. So what that means is that we will start our equation off by doing, by flipping it. So it would be 3CO2 gaseous, which we got from the product side of the first equation, plus the other term, 4H2O liquid, is equal to, now we flip it again. So we write the reactant side on the products. So it'd be C3H8 gaseous plus 5O2 gaseous. And then because we flipped it, we would have to multiply the change of H by -1. Because if you think about it, it's basically being flipped in the opposite direction. So it'd be -1 times negative 0.0. Sorry, it's running off the page a bit, which we got from the first equation. So now we can just draw our big arrow, big line, and then we can, sorry, it got a little blurry there. Okay, so now we can cross everything off. That's the same on the left and the right side. So we can see here, oh, the 4H2O. That would be canceled off. And then, can you guys try and find what the next term would be that's canceled off? 3, 2, 1. Yeah, we can see the 3CO2. That's absolutely correct. So 3CO2 would be canceled off on both sides. So then we see that that's not everything that's canceled off because I did not look at that. So that would be the 3, 2, and then the 5. That is also canceled off. That is everything. So then we would rewrite this as 3C solid plus 4H2 gaseous is equal to the one on the right side, C3H8 gaseous. So then we would just want to add every single term up over here, which I will quickly do that right now. Sums up to be 103.7. So that would be that the change of H is equal to negative 103.7, which would be our final answer. Okay, moving on, we have our second problem, which is asking for what energy output in kilojoules is needed to decompose 36.00 grams of water, which is H2O. Okay, so let us begin. Here we're given 36.00 grams, so we can just write 36.00 grams times, now we have to try and cancel out the grams. So for 1 mole, however much the AMU is of H2O. So I went ahead and calculated that. That's around 18.02. And I got that by just adding up the atomic mass of 2 hydrogens plus 1 oxygen. So 18.02 grams. So now the grams cancel out. Now, because the answer needs to be in energy, how do we implement that? So we can see our scale factor here would be plus 571.6 kilojoules for every 2 moles of H2O. So how would we do that? We want the moles to cancel out here. So we would write the moles on the bottom over 2 moles. And then it would be 571.6 kilojoules. And that's simply just the scale factor. So grams cancel out, moles cancel out, and we're just left with this. So all we have to do is do 36.00 times 1 times 571.6, and then all of that divided by 18.02 times 2. And that should roughly equate to around 571.6 kilojoules. And then it's rounded to 4 sig figs because excluding this one here, the least amount of sig figs is 4 across all of these 3. Okay, moving on, we kind of have the flip problem where we're asked to find the mass of NH3 that is produced when 500.0 kilojoules of energy are released in the following reaction. Okay, let us begin. So first we're given 500.0 kilojoules. So we can just write that down, 500.0 kilojoules times, now we need to try and cancel out these kilojoules. So how might we be able to do that? We can write kilojoules on the bottom of the scale factor. So the scale factor would be negative 92.4. So negative 92.4 kilojoules for every 2 moles of NH3. So that's 2 mole. So then that would cancel out the kilojoules and kilojoules. Next, we're trying to cancel out the moles. So because the moles are on the top here, we can just write the moles, 1 mole on the bottom here. And then we have to try and figure out the grams of NH3. So by looking at our green table here, we know that N's atomic mass, which is nitrogen, is 14.01. 14.01 plus next 3 hydrogens. So plus 1.008 times 3, which equates to roughly 17.03 with a sig fig rounding. 17.03. Okay, and then that would be in grams because we're trying to find the mass in grams. So kilojoule would cancel out, moles would cancel out, So now we are just left with the grams. So we would want to multiply 500.0 times 2 times 17.03, and then all of that divided by negative 92.4. So let's go ahead and do that. So we can see our parentheses there. It'd be 500 times 2 times 17.03 divided by negative 92.4. And then we are left with about negative 184.3. But then we have to think, mass can't be negative here, so it would just be positive. Because, so then the answer would just be 184. Sorry, my lead keeps breaking there. 184 grams. And then we can see here that the least amount of sig figs here are 3 sig figs, which is why we just round to 184 grams. Okay, perfect. To 184 grams. Okay, perfect. Okay, for this next problem, we are tasked to find the delta H reaction of this following reaction. Delta H for that H2O would be negative 241.818. So we would write negative 241.818, and this is in kilojoules per mole, times however many H2Os there are. So 6 moles of that. So that'd be times 6. So then for this next one, we can do it similarly, which would be 4 CO2s. So then how is that composed? What is the simplest way? That would just be 4C and then plus what's left? 4O2. So this C's, the carbons, can be left just by themselves, and you do not have to write them in the C2 form because they can exist just by themselves. So then that would be delta H reaction is equal to the kilojoules per moles of CO2, which would be negative 393.509 times however many CO2s there are, which is 4. Okay, so now we need to see the opposite side, which is the reactants. So we can see the 2C2H6, C2H6, how is that basically destructed? How can that be destructed? So we can see that that would just be 4C plus 6H2. Again, very similar to the formation part. The C can just exist by itself, so it's 4C plus 6H2 because H needs to be in that the 2 form with the 2 of them. So then be HRXN equals to, for C2H6, it is negative 84.68, so negative 84.68 times however many there are, which is 2, times 2. Then for the last one, 7O2, how can that be destructed? Well, that's already in the most simplest form that's possible, so we would just write that as 7O2. And then the delta H RxN of O2 is just 0 times 0. And then it's also important to note that because these are like being destructed, we have to write the negative 1 because we're multiplying everything by negative 1 here because we're basically like flipping it. So it'd be negative 1 times the 7. But this way to do it is actually very, very laborious, and there's a much simpler way to do it, which is just the summation of the HRxN of the products minus the summation of HRXN of reactants. So by doing this, we can see that that is exactly what this is, where we're just doing the summation of the change of H of the products minus the reactants. So what would that be? What would that get us? So we would just write it all out as the products, which is negative 241.818 times 6 plus negative 393.509 times 4. Sorry, got blurry there. Minus, I'll just draw this arrow here so it's a little more clean. So this minus negative 84.68 times 2 times negative 1, which would be for this one right here, plus 0 times 7 times negative 1. So that's that. So then if we plug that all into our calculator, we will see that the answer would equate to around negative 2855.58 kilojoules, which would be our final answer. Okay, for this next problem, we are tasked with finding the equilibrium temperature for this following mixture with lead, silver, and water. So for equilibrium temperature, we know that we would have to use Q is equal to MC delta T, where Q would be equal to the heat energy gained or lost. M would just equal to the total mass of the substances. C would equal to the specific heat. And then delta T would be equal to the total change in temperature. Okay, so let's do this. So first we have to write the Q is equal to M cap for the lead. So what would that be? That would just be M, which would be 80.0 times the C, which is the specific heat, 0.129 times the change in temperature. So what exactly is change in temperature? That is just final temperature minus initial temperature. So it'd be TF minus whatever the initial temperature is here, and that's given us 200. So minus 200.0. Then we would just do plus the next one for silver. So what would that be? That'd just be 120 times 0.235 times TF minus 25.0. And then, sorry, I ran out of space there, but the next one for water would just be plus 50.0, which is the mass, times the specific heat, which is 4.184 times TF minus 15.0. So that would be our first equation there. So the next thing that we would need to do is to multiply all our terms out. So grabbing my calculator here, we would first have to do 80 times 0.129, which is 10.32. And then we see here that it's 80.0, so that's 3 sig figs. So we just round to 3 sig figs. So that would be around 10.3 TF. Because of distributive property, we would multiply these two into this and into that. So it'd be that, and then we would do 10.3 times 200, which would get us 2060. And then 2060 is already in 3 sig figs, so it'd be TF minus 2060. So that would be our first term, if you will, for lead. Next, we would add that with 120 times 0.235. So 120 times 0.235 gets us 28.2. So 28.2 TF, because again, we're multiplying this into that and then into that, TF minus, and then again, that's already in 3 sig figs, so that's what we need, because that's the least specific amount of sig figs, times, so we do that times 25.0, which is the initial temperature that's given. So that times 25 would give us 705. So we see here that it is 3 sig figs. 3 sig figs would be minus 705. And then plus our next ones would be 50.0 times that, and then whatever that is, times that, and then times that. So it would just be 50.0 times 4.184. So we would want to be into 3 sig figs because that's the least specific. So it would just be 209. So that'd be plus 209 TF. And then the last term that we have here would be 209 times that negative 15.0. So that'd be 209 times the 15.0, which would be 3135. And then we would want it to be 3 sig figs because that was the least specific amount here. So it would just be 3140. So minus 3140. So then that would be our step 2. So the next thing that we would have to do is combine all of our like terms. So that would just be 10.3 TF plus 28.2 TF plus 209 TF is equal to 2060 plus 705 plus 3140. So then putting that all into our calculator, we can see that 10.3 plus 28.2 plus 209 gets us 247.5. And then we would want to be with 3 sig figs because that's the least specific. So that would just be 247 TF is equal to 2060 plus 705 plus 3140, which gets us 5905. And then that again, we would want to be 3 sig figs. So it would be 5910 is equal to 5910. So then the last step would just be 5910 divided by the 247 TF, divided by 247, which would get us 23.9. So our final answer would be 23.9 degrees C. Thank you guys very much for watching, and please consider coming back to watch more and more videos. I would really appreciate if you would send more and more requests in, so that way we can keep making some videos. Thank you very much and have a great studying session. Bye-bye.